Today we will be discussing the chi-square distribution. Chi-square distributions can be used to test the frequency of distributions, test the independence of two qualitative variables, and test the equality of proportions. We'll begin by going over the steps to using this method and then apply it to an example problem. What we'll be going over today is the equality of proportions test. Step 1 is to state the null and alternate hypotheses. The null will be that there is not a relationship between the variables. The alternate will be that there is. You also will want to find your assumption. This is the probability that one of the two variables will happen, and this assumption statistic is how you will calculate your expected values. This brings us to the next part of step 1, which is to calculate your expected values. Multiply your assumption statistic to your totals to find the expected values. Step 2 is to calculate the chi-square statistic. You do this by following the formula. Observed minus expected squared over the expected. You must do this for all of your values. You then add all of these together to find your chi-square statistic. Step 3 is finding your degree of freedom. If a two-way table is not used, follow the standard procedure and take the sample size and subtract by 1. If you are using a two-way table, take the number of rows minus 1 and multiply it by the number of columns minus 1. Then refer to your critical chi-square table and find the critical chi-square statistic. Use the numbers under the 5% and 1% column. Step 4 includes determining if we are going to accept the alternate hypothesis with these calculations. If your chi-square is greater than the critical chi-square at 5%, we have enough evidence. If your chi-square is greater than the critical chi-square at 1%, we have significant evidence. If your chi-square is less than the critical chi-square at 5%, we do not have enough evidence. The fifth and final step is to summarize. Based on what we just determined above, we must write our conclusion in proper sentence form. For example, a summary may sound like, since 16.45 is greater than 9.22, we have significant evidence to accept that there is a relationship between the two variables. Now we are going to work on an example problem. Determine if there is a relationship between receiving financial aid and the chosen major. Please look at the table shown, which represents the number of students receiving financial aid by major at a small school in Nebraska. Our null hypothesis is that there is no relationship between receiving financial aid and the chosen major. Our alternate hypothesis is that there is a relationship between receiving financial aid and the chosen major. The assumption is the probability of receiving financial aid, which is 230 over 1,000. The proportion then is 0.23. We will then use 0.23 to multiply the statistics in our table to calculate our expected values. The best way to do this is to add sections to the two-way table for your expected scores. It's important to understand we are assuming 23% of students will get financial aid regardless of their major chosen. Since the total of liberal arts majors is 270, we will multiply 270 by 0.23. This gives our number for the people that did receive financial aid, 62.1. Then subtract 62.1 from the total, which is 270, to calculate the liberal arts majors that are expected not to receive financial aid. Continue this process for science and education majors. We will now use the information in the table, which has our observed and expected data, to follow the chi-square formula. You then follow the chi-square formula, the sum of the observed minus expected squared over expected. You should do this process to all the various statistics, which means that you should apply the formula 6 times. Then add all of these numbers up together. This is your chi-square statistic. We found that ours was 4.26. Next, you will need to find your degree of freedom. There are 2 rows and 3 columns, so 2 minus 1 times 3 minus 1 is 2. When looking this up in my table, the critical chi-square at 5% is 5.99, and the critical chi-square at 1% is 9.21. Since 4.26 is less than 5.99, we can conclude that we do not have enough evidence to accept the alternate. Our final step is to summarize. We do not have enough evidence to accept that there is a relationship between receiving financial aid and the chosen major.